Welcome. Thank you, Vidisha, for starting recording. Welcome to the Hydronic Heat Working Group, May edition. I'm going to read the boilerplate as people are filtering in. So AWHI is a member-supported collaborative of professionals from across the U.S. This diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance is important at all times. At this and other AWHI meetings, participants should not discuss competitive pricing, profitability, allocating markets or customers, or promotion of a particular product or accessory. So today's agenda, we are going to be talking about early insights from air-to-water heat pumps and programs. So thank you very much, Phil and Matt, Christie, and Dave. Dave is on, I see. Hi, Dave. That's going to take about 45 minutes of the call. The rest of the call is kind of our opening and closing. I've decided to move the open discussion of anybody's reports and presentations earlier, and I'm calling that warm floor because it's a funny pun. But first off, let's do introductions. If there's anybody that is new, please feel free to raise a hand or come off mute, or you can drop in the chat if you don't feel like talking, your name and pronouns, organization title. Yeah, Scott.
Hi, Scott Spielman, he, him. I am the research director at Ecotope.
Welcome, Scott.
Thank you.
Charlie?
Yeah, I'm Charlie McCracken. I work for Clear Result. We manage, well, I'm the trainer for the Rhode Island Heating and Cooling Program. And we've been working on proper charging and proper sizing for the 20 years that I've been part of this program. And we have a test procedure for mini splits that I'd gladly talk to anybody about. They can verify you got it right rather than just guessing. So.
Awesome. Welcome, Charlie.
Yeah, and I can go too, John. So I'm John Blofis with Daikin, work on our utility business development team, part of a group of 4 of us that cover the US. And yeah, I'm interested in keeping up to date with what's going on in the air-to-water heat pump world as those become a bigger focus for our company and our team.
Great. Yeah, welcome everyone. Thank you new folks for jumping on and returning folks as well. So the purpose of this working group is that we want to keep the conversation going about air-to-water heat pumps. I think with federal uncertainty and movement, that's especially important. This group is meant to centralize understanding of air-to-water heat pumps. You know, we're thinking about research, best practices, programs, products, the whole landscape. It is, to my knowledge, the only group that is doing that for this technology. And then we have some secondary conversations about a variety of topics, including cooling, combi systems, thermal storage, the whole gamut. So I wanted to move to this warm floor, which is, please come off mute, raise your hand, or drop in the chat, any new reports or presentations, any updates on activities, projects, or programs you want to give. I'd also like to expand this in this current climate to, feel free to give us an update on a delay in a project or whether a project was canceled. I think not everybody is fully apprised of what is going on across the spectrum and what things we thought existed might not, or whether things are delayed. I'll start with our project for Focus on Energy. We have an air-to-water heat pump field study with Focus on Energy installing at some sites across Wisconsin. We have installs at one small multifamily 4-unit building that's dual fuel with heating and space heat and domestic hot water. We have one install at an all-electric site with the same domestic hot water and space heating that's single family, and an install that has cooling and space heating and is dual fuel. And we are maybe going to get a new construction site soon. But our project has been delayed, so our final report won't be until Q2 2026. Yes, Charlie.
Yeah, this summer we have a University of Rhode Island engineering student as an intern, and I'm going to be doing an air-to-water heat pump study in Massachusetts and Rhode Island. I've got one LG site, one with, I'm not sure what the brands are, but we've got at least 4 people that have signed up to let us come up and model the systems and do load calculations and see what they're doing, and then monitor the fuel bills and see how it worked out for them. We did this about 3 years ago with a different intern, and we found that the average heating system was twice the size of the load calculation, and the heat pump was doing 3/4 of the load, despite being significantly smaller than what the oil burner was. We're looking to do the same thing again this year.
Thanks, Charlie. Scott.
Thanks, John. Just wanted to report that myself and a few others put together a code proposal for the Washington State Mechanical Code to allow for R290 refrigerant, which is propane refrigerant. The way it operates is it creates an exception to UL for monoblock air-to-water heat pumps that are installed in low probability applications where manufacturers can certify to the IEC standard as opposed to the UL standard. So we're seeing how that goes. And some folks in New York are looking at doing the same thing for New York State. Also,
who is some
Ecotope,
folks in that sentence, Scott? I'm curious.
Let's see, who was I working with? Anne Erling was one of them. Do you know her?
I don't.
I could look. There's like a huge email chain with a bunch of people, and basically I sent them the code proposal that we did in Washington.
Okay.
And then they were looking at doing it in New York as well. But if you want me to connect you, I can.
Yeah, I would love that, Scott, if you can connect me to that group. Because yeah, we're same thing. We're trying to get R290 into New York for the same reasons and with the same restrictions. And I'd love to see how that effort plays.
Okay. Do you want to just drop your email in the chat and I can?
Yeah, we'll do.
Loop you in. Thanks. A couple other kind of minor updates. We did a M&V on a new Daikin Altherma combi system in California. We just finished that report with A2 efficiency, and that should be coming out soon. One of the things that was interesting is the controls were kind of the biggest challenge in those indirect combi systems. And we also published a report on a 2-pipe changeover system we're calling Eco 2-pipe, a feasibility study on that. And we have a demonstration project in Washington where we're going to use the LG air-to-water heat pumps and monitor a 2-pipe changeover in a residential multifamily application.
Awesome. Thank you, Scott. Yeah, I look forward to reading that study.
Yep.
John, I just had a follow up on the 290 piece. It sounds like is Washington and New York, is that sort of the leading edge in terms of attempts at legalizing the use of R290 in HVAC applications, as far as you know?
As far as I know, Washington's the only state that's actually formally submitted a mechanical code proposal that would then allow for R290, because the mechanism that's preventing R290 right now is the UL listing.
Oh, okay.
And so UL is required, through the mechanical code, so you can't get a permit unless you have a UL listing on your heat pump. Right. And the proposal was approved by the technical advisory group, and then it goes for final approval sometime in the fall. It's not in the code yet, but it's looking good.
Is there another pathway to work with UL to have them certify or give their blessing to 290 systems, or is that not really a practical pathway?
It would be great if we could make that happen, but I'm not sure that UL has any interest in making that happen.
Mm-hmm.
And we just have some kind of I think there are some challenges with UL because they were a nonprofit for a very long time. In the early 2010s, they became a for-profit company that is basically making what functions as laws for manufacturers through the mechanical code. And there are a lot of there's a lot of interest in what they're doing from different sectors of industry who would have vested interest in them writing rules in particular ways.
Right.
And so R290 would basically blow the door open for people to be able to use a refrigerant that's not patentable, that's highly efficient, that anyone can get their hands on. And there's corporations with a lot of money who don't have an interest in that happening. So
I think this is a great
table
discussion.
This one for another time.
Well, we may end up coming
can.
back to this discussion at the end of even this set of presentations. So, but if not, yeah, let's chat about it at a different time. But I do want to make sure our presenters have a chance to get through their content, and there's relevant content in there. So, we are going to move on to our three presenters. My hope for the format is that everybody has a max of 10 minutes to present their slides. And you know, maybe we'll take up to 2 questions after each, and then we can have a larger set of questions at the end, and discussion. So I will be timing folks. I will chime in if you go over 10 minutes on your slides. You probably won't, but I might interrupt you. So without further ado, I'm going to, and I'll go ahead and control the slides because there aren't that many per presenter. I will pass it to Phil to start us off.
Great. Thank you, John. Good morning or good afternoon, everyone, depending upon where you're at. Phil Bickel. I am the HVAC program manager here at Efficiency Vermont. And so I manage our air-to-water heat pump program. So I'm going to tell you a little bit about the history of the program and where things are at right now. So yeah, let's go on to the next slide. I will give I'll breeze through these. I got a couple of slides, just a little bit for folks who are not familiar with Efficiency Vermont. As I was introduced, I am VEIC is our parent company, and so I work for VEIC, and we run the Efficiency Vermont, and this is the first energy efficiency utility in the nation. We've been around since year 2000. So our goal is to basically help Vermont transition to more affordable, low carbon energy. And so we work with all kinds of entities within the state, and we have been recognized by Energy Star as a Sustained Excellence Partner. My next slide, I won't talk about everything on here. This just kind of highlights some of the impacts that we've had on efficiency over those years. And I think kind of the 2 of the biggest ones kind of go along with what the topic today is about, the jobs that we have, the number of jobs we've interacted with in energy efficiency within the state of Vermont, and the number of efficiency excellence members. That's our contractor network. So we work with 650 contractors in the state of Vermont, which for those of you from bigger states, obviously those are not huge numbers, but for Vermont, it's pretty good. So let's move on to the next slide. A little bit about our program by the numbers here. So the program was originally launched in 2019. So we're about 6 years into this now. And if I've been told correctly, we were the first state to have a prescriptive program for air-to-water heat pumps. So My predecessor, Jake Marin, when he created this program, when he launched it in 2019, before he did so, he did a lot of work doing a lot of outreach with the folks who were been in that market for a while. So a lot of the smaller manufacturers of air-to-water heat pumps. And he worked with them, worked with contractors, and got a lot of input before he basically created what we have here now today as the performance criteria. And so this was the main requirement for the program, is that determine that an air-to-water heat pump to be eligible for a rebate in Vermont would have to have a COP of a minimum of 1.7 at A5 W110. And I don't know if that numeric has been around for a while, or if this was something Jake kind of created with the input. But basically what that means is that at an outdoor air temperature of 5 degrees Fahrenheit and a leaving water temperature, so water output from the heat pump of 110 degrees, the COP must be at least 1.7. So that's really all we had for that, for the performance, and that's self-reported by the manufacturers, and they're basically typically reaching out to Efficiency Vermont to have their products added to our qualified products list. So again, the rebate's prescriptive. We do restrict this rebate to contractors or the installing contractors have to be enrolled in Efficiency Vermont's Efficiency Excellence Network air-to-water heat pump trade group. So basically, they need to be a member of the EEN, and that's just to ensure that the contractor has gone through some general trainings, works with is enrolled with the state Secretary of State as a business, and they're fully licensed and insured. And then that's just to be in the EEN. And then to join the trade group, we require that they have gone through an air-to-water heat pump manufacturer's training before they can join, or before they can get their first rebate processed. And the reason why we do this is, again, sort of a emerging technology still, and a lot of contractors aren't aware of it. At that time, the program was launched, most of the brands that were being offered were not brands that the average HVAC contractor was familiar with, or at least contractors who've been installing heat pumps. So we wanted to have some quality control and ensure that the contractor is familiar with air-to-water heat pumps, and if not, that particular system that they'll be installing. And then also that there is some good post-installation support for the customer. So we have a little bit of leverage from the contractor to have them remain in good standing with the EEN. So if there's a problem between the contractor and the customer, we can kind of act as an intermediary to a limited degree to ensure that the customer has a satisfactory experience with the project. Excuse me. So the rebate is $1,000 per ton, and that's up to 6 tons per unit. And so that typically covers the average home in state. And then a $500 bonus we have on top of that for income eligible customers. So that's how the program was first launched. That's how the rebates remain today. And in the 5.5 years or so, we've had 150 completed projects. And I put down here just the split between the monoblock and split systems, just to sort of a little bit of insight into how that work, or how that's going. 60-40 split. I don't really have any more insight into what is making people making the decision to go in either direction. I think some of it has to do with availability of infrastructure and just what system or what brand the customer is interested in installing. Today, the qualified products list includes 18 brands and 56 different models. And to compare from when just 2 years ago, so 4 years after the program launched, we only had 9 brands and 33 models. So just 2 years now, we've doubled that. A lot of more brands. A lot of the major manufacturers now have air-to-water heat pumps, and other ones have expanded their product line. So there's definitely been a good amount of growth in this market in just a couple of years, and I think we're expecting to see some more as other manufacturers have been indicating that they'll have something products out in the next year or so. So my next slide, I'm not going to go too deeply into the insights because I know Matt is going to talk much about that. I just wanted to just share a little bit about what we see or what we're hearing in feedback. What are some of the advantages of air-to-water heat pumps that customers like and some of the contractors like? Big one is that this is essentially just a drop-in replacement for a boiler that's used for radiant heating or other low temperature distribution systems. We have a lot of boilers in Vermont, not as many radiant heating, but it's still definitely pretty popular. So that's where we've seen, as for retrofits, the biggest area where there's the most adoption. It's also been a great option for new construction or people who are doing a major renovation of their home and they got to rip up the floors, and they're choosing to go with radiant heating for that. Another big bonus, not bonus, but a factor that people are really interested in is the ability to incorporate domestic hot water, so to leverage water heating as well. And then part of that is that the ability that we could use the thermal storage for future flexible load utility rates. There's been some attempts to do a couple pilot projects in Vermont. I think there are a couple ongoing, but I know our utility partners, as they are working to develop residential flexible load programs, they're looking at air to water as one of those, as a technology that they can really, that'll be a really advantageous to flexible load. We are seeing a lot of awareness of air to water heat pumps, but the growth has been kind of limited. We're kind of flatlining around like 30 to 30 some installations per year over the past 5 years.
You're at 10, Phil.
Excuse me?
You're at 10.
At time? At 10. Okay. Yeah, and so we can get in, Matt can go in more. That's pretty much everything I had. Thanks.
Thanks, Phil.
Though we can do a few questions before we move on to Matt.
Oh, okay.
Oh, okay. Cool. Yeah. And there's my information if anybody wants to contact me afterwards. But if anybody had any questions now about the program for it.
I have one. Oh, I'll let Dave ask.
I had just one more kind of more general market question about the perception of radiant heat in your market. Like, is that considered a kind of a premium style of heat particularly in new construction? Like, is that something that people upsell and say we're building these homes and we're doing radiant heat?
That's a great question. I don't see a lot of or have a lot of interaction with residential new construction with that market. So I'm always seeing when the projects come in, and then if it's checking off the box that it was new construction. My sense is that it's not developers and home builders. It's the folks who are working with a contractor to build their home. Like, they bought some land, they're going to design and build a home, and they want to go with the most efficient thing and radiant heating, like that. Not seeing it in like developments or like multifamily developments that are being built.
Peter.
Okay. Yeah.
And Vidisha and Charlie, you'll have to wait till the end to ask your questions.
Yeah. Or we could bring it up in chat. I know I've done that in previous meetings. But thanks for that presentation, Phil. Very interesting to see what's going on over in Vermont. You mentioned that there's growing interest from Vermont utilities around dynamic prices and incentivizing load shifting that way. Has Vermont historically done other sorts of programs like traditional demand response or virtual power plants?
Yes, we've definitely had that in the past. Our largest utility has demand response, virtual power, and then also curtailment rate. So, but they're also working towards what they're calling flexible load, which is basically increasing the usage in an off-peak time so that you can coast during the late. So thermal storage for an air-to-water heat pump would be the residential example for that. So that looks like where things are starting to go. It's definitely slowly gaining some momentum.
Sounds good. We'll be very interested in talking as you make progress.
Yeah.
All right, now let's move it along to Matt. Thank you, Matt. Thank you, Phil.
All right, so let's talk about New York. All right, so New York followed suit, essentially. Mass Saves actually followed suit first, and they did some coordination. They used the same QPL as Efficiency Vermont came up with, as Jake did back in the day. They did grant some exceptions to some ecoforest products that are R290. So going back to that earlier conversation, when Mass Save built their list, they essentially had like a special project that was getting special exceptions to test R290 products, and so they allowed this ecoforest project to get on the list that Vermont wasn't ready to do because of the limitations on R290 use in the code, and they didn't want to have it on the list. So those two lists split. When New York came to town, we wanted to follow suit to make it easier on manufacturers to only have to adhere to one list, kind of like a NEEP style concept. So we jumped in at the same thing, the 1.75 at 110 supply temperature, use the same QPL, and we actually coordinate that QPL. Hugh Henderson, who's on the call, is the main person who's in charge with helping to do that coordination and accepting new products into the lists that cover both New York and Vermont simultaneously. Again, trying to make that easier on the Daikin's and LGs of the world that are adding new product lines into this marketplace pretty quick. We got started first. The New York Technical Resource Manual working group developed a measure to quantify the savings claim, or the MMBTU carbon reduction claim, that we would take as a state from air-to-water heat pump. And Hugh also was deeply involved in that. It was the lead engineer that authored that. TRC helps manage and work with the technical committee as well. So we were both involved in getting that through. Once that was through and finalized in the summer of 2023, then it took about a year for the programs to take advantage of that TRM measure and actually produce an offering. And so in that process, we built, what are the contractor requirements? What's the quality control inspection requirements? What data collection do we want to do on the application form? All of those details, TRC supported with some of help from Hugh, some help from John Siegenthaler, some help from ICF, who's the implementer of the New York State Clean Heat Incentive Program. TRC's rules were quality control inspection for the upstate utilities on New York State Clean Heat. But we kind of collectively, with the utility as well, built this program and all of its apparati and launched it in March of 2024. The incentives are by $10,000 per $10,000 of BTU. Sorry, there's a typo on the slide there. That's on me. But it's 500 to 1,600 per 10,000 BTUs rather than per ton. So it's in the same ballpark, right? A ton is 12,000. 10,000 is easier to do math on, is the idea for that. So you're same thing. Your 50,000 BTU house, which is about normal in upstate New York for a medium-sized house with a decent shell, right? You're getting, depending on the utility you're with, 500 in Central Hudson, 1,600 in National Grid, 1,000 in NYSEG and RG&E. So we have territorial differences in the value, but you're looking at somewhere between $2,000 to $8,000 per house, ballpark, depending on the size of your house and which utility, your territory you're in. We've only had 4 projects, 4. So very slow uptake. They're all the same installer. They're all the same system type. They're all in kind of the Hudson Valley to Albany area in upstate New York. They're fine. They're really high quality. TRC has inspected all 4. They all got passing scores immediately. But the program is not accelerating. It's not launching. It's not, making that kind of accelerated progress or process that we were hoping for. So far, the incentives that it's based on, like what's in the TRM, is only for the heating portion of the potential of air to water, right? Even if they did install cooling, there's no added incentives or saving claim for the cooling efficiency. Even if they did tap it into domestic hot water, there's no savings claims for the electrified hot water load. The TRM committee was working on that. They had a measure in the middle of development. Hugh might be able to speak to that in more detail than I can, frankly, because he was in the middle of that as well. But that got pulled in May and kind of taken off the table temporarily. So we don't know when that'll come back into the fore, but at least that's momentum and intention towards kind of honoring the tri-mode reality of the potential of air-to-water heat pumps within the New York State program eventually. I don't know when that'll come back around. But that's where we are in New York. Yeah, go ahead, you.
Hey, Matt. Yeah. So we always actually did heating and cooling savings, but incentives are only based on heating savings.
Good point. Thank you for that clarity.
And then you're right. The new change is to include domestic hot water heating savings in the calculations, and that's all done. It's not clear when it's going to be released, and it's not clear if that'll show up in the incentives as well.
Yep. All right. So now that's the program side of it. Broadly, in terms of next, we can go to I think I can click next slide, can't I? All right. So here's kind of where my thinking is on air-to-water heat pumps and program acceptance and getting into the market faster broadly from helping to work on this and helping other clients, including NIA and others, think about air-to-water advancement, right? We're working in the cold climates, right? So we really need a heat pump, whatever style, ground source, air-to-water, that really produces in the cold. And New York in particular is really focused on whole home, right? No backup, nothing else, just the heat pump, right? And that's sort of their focus on decarbonization and the idea that you can't decarbonize 95%, right? You gotta go all the way, or else you also run into the issue that Mass Save has in the past as well of if you have two systems at some higher than hoped for percentage, homes just revert to their fossil heating and they're not actually using their heat pump efficient electric heating. So we need products that really truly work in cold climates, really truly fulfill all of their efficiencies at the extreme colds not quite extreme, but quite colds of upstate New York, climate zone 6, design temperatures around 0 with, polar vortex events that get into the -15 range pretty frequently. We need ones that meet the design loads of an entire building in that climate. We need ones that have really good seasonal heating and really good peak COPs, and continue to operate down into those polar vortex events, right? Don't just cut off. The challenge we're seeing on the way to that kind of concept is one that Phil gestured towards: limited drop-in applications, right? We have 42% hydronic boiler heated homes in upstate New York, but most of those are hydronic radiant baseboard, right? Which has a supply temperature of 190, 180 design need. And the current heat pumps on the market really kind of top out at 140. There are some that are starting to come to the market higher, the 160, 170, 180 range. Some of those are in market. I think LG has one that's in market, but I'm not totally sure exactly where we stand. That's a sea change that might make things better. 170 coursing through. Baseboards are typically oversized anyway. You need a 10 feet. If they put in 15 for fun, right? You might have that with a 170 or a 160. But they're reaching that 160 not at quite the same efficiencies as they get to the 130, 140 degrees. So that's still a little bit of a triangulation to make that work. So these aren't good for the current drop-in applications right now, obviously, right? Works in new construction, as Phil said, great. Deep retrofit, okay, awesome product there. Works when you have radiant floor or low temperature. Yeah, you like that picture? I don't even know where I got it, Charlie. It was like an online, show me excessive radiant piping, please. Got that photo. Right, it works if you add additional radiating surfaces, right? You have your baseboards, then you add a couple panels here and there to complement that and supplement and add more radiating surface than you started with. It works if you reduce the load drastically, right? So that the load reduces, so your baseboard that you have and the output you get at 140 degrees now becomes sufficient to meet the load. It could work if you add hydronic fan coils to supplement, right? Instead of radiator panels, fan coils, ducted or ductless. That has the added benefit of maybe allowing cooling, right? And then the newer products, as I said. But right now, just the market is limited. How many homes could I walk up to in New York and say, here we go, we're going to turn this into air to water, and you don't run into some well, not really, or only if I do these other things that are expensive or hard, and I, by the way, also have this other product line called an air source heat pump that's totally fine too, and I could do it tomorrow. All right, and you just get into that world where the air to water complications versus the air to air ease, relative ease or just boiler swap out, right? Especially with fuel costs, right? You can kind of it just channels people away from air to water, except for niche cases. The lack of standards makes it hard, right? There's no HSPF, there's no SEER, there's no AHRI ratings, there's no there's no universally accepted industry standard of efficiency of COP, right? Of seasonal COP, which is really important, or even like peak COP or any SEER or an EAR. Like there's none of that, or a peak heating efficiency. There's a lot of initial data from initial projects and from the manufacturers that purport and show these things are amazing. They're peak shaving, there's load shifting, they're great seasonal COP, but there's no way to point to kind of one thing that everyone sees and trusts and has the backing of like the government or something big like that, or a large trade organization. And that just makes it really tough for utilities to jump on board with, right? It feels novel, it feels bespoke, it feels like I'm trusting the manufacturers a lot. And I need to be a good steward of ratepayer funds with my incentive dollars, and I need to have really guaranteed savings claims. And I'm just going to keep out of this market until I get something more solid that I can glom onto. And that was a bit of a challenge in New York with the New York utilities, but the DPS kind of pushed it and pressed it, and we got to where we were. There's also inconsistency between the manufacturer reported data themselves, right? You have a triangulation problem where you have different COPs and capacities at different leave water temperatures, different outdoor air temperatures, right? Different distribution styles. You have all these variables that all come together. It's like, and what gets reported by what manufacturer is all over the place. So there's not standardized. And so that's where Dave's going to talk next about an effort to try to create potentially an air to water heat pump NEEP list where standardized data points, or at least, some would have some value to at least compare apples to oranges across product lines more easily.
Matt, you're at 10.
I'm at 10. All right. And then I'll fly through the rest then. And then the other one is that a lot of what's driving the change is adding cooling, and adding cooling with air to water right now is difficult because of the distribution, right? You need to add some kind of hydronic fan coil somewhere, which changes piping, which changes everything. Hard to do. Or similarly, the comparison product, air source heat pumps, cooling, boom, it's right there. So that just makes it a little bit more challenging as well, except in new construction. And that's it. Thanks for the warning, John.
Yeah, no problem. Yeah, we can take 2 questions before we move on to Dave. I did have a question. I actually need to look at the slide though to go back and figure out the question that I was going to ask. Yeah, the 4 projects to date, all from one installer. Are you doing new construction, or were these retrofits?
All four of those were retrofits. I think 3 of them were deep, like gut rehabs, though, like total system change, deep change outs, and 1 was a radiant floor. That's my memory, but I'm doing that from memory, John. So. Yeah.
And did the installer add any services or, like coils, fans, anything like that?
I wouldn't want to.
Okay.
Yeah. Speculate live on the phone. I'd have to pull up those projects and look at where they were, or talk to Terry himself who did them. So.
Okay. All right. Well, looks like we can jump to Dave. Thank you, Matt. It's great. Dave, give us the NEEP perspective.
Great. And you have, I was just going to say, oh, shoot, do I need to project my slides? You're all set.
I will control this. I am actually, for those of you who haven't interacted with the new Present in Teams feature, you as the participant can click the slides forward even when the presenter is not clicking them. So if somebody else is driving for you, you may believe that you are driving when you are not, which is a funny, it's a funny side thing of I really like Present in Teams, but it is weird. So yeah, Dave, take it away and I'll click through slides for you.
Okay. Great. Well, yeah, thanks for connecting with NEEP. The timing is very good because we are actively, very imminently likely to be posting and publishing a request for comment about possibly adding a air to water category to our existing cold climate air source heat pump specification and product list. So good timing, and I'm just going to go quickly through what our existing thinking is here. Matt covered a little bit of the context here. We're operating here in the Northeast, lots of interest in driving adoption of heat pumps. We have made quite a bit of progress on the air-to-air side. We are unique in that we have a lot of hydronic distribution, a lot of boilers in our existing building stock. As Matt pointed out, that a lot of that is designed for high temperature water. And so we're looking, I think programs policy folks are looking for more of a drop-in replacement way to replace those existing boilers with a heat pump solution. Next slide. And I guess to add to that context, yeah, there's already a number of programs in the Northeast that are promoting air to water heat pumps. Some of the barriers that Matt talked about in terms of standardization around specifications and performance is certainly relevant to the broader role that that our product list and specification that the existing product list plays in the market today for split heat pumps, air source heat pumps. For those that aren't familiar with the cold climate specification, I flag kind of the current kind of bifurcation involved in the specification today. We have kind of a series of performance requirements, and as well as a series of reporting requirements that is really around providing more transparency around a range of extended performance at various temperatures. So we again rely on more typical standard industry seasonal ratings and other efficiency metrics, but we also include sort of this set of extended performance data, and so just wanted to flag that we have sort of this existing model of seasonal performance mixed with sort of more of a performance map. And as the other folks talked about, this is absolutely an engineered solution. So the idea of bringing more performance data, more transparency to what these systems can do at different temperatures is valuable to the market. Next slide. So some of the high level questions that we're considering are the just general market need and opportunity for NEEP to add this category. Defining the category, there are a number of different technical definitions of this product that we all know when we're looking at it, but in the lexicon of standards on AHRI and DOE, etc., there's landing on sort of an agreed upon definition of what products would fall under this specification and what others that might fall out, I think is definitely would be part of our process here. Selecting performance metrics like the COP at 5 Fahrenheit 110, test procedures that would or wouldn't be necessary to determine those performance metrics, and then selecting what these tables of performance data should and would include are all questions that we are likely to seek comment on. Next slide. And this is just an example of how we might leverage our existing performance tables. These are kinds of data that we collect from outdoor temperatures from 47, 17.5, lowest catalog temp. The leaving water temperature here would be the new feature for these performance tables. We normally that is usually the indoor temperature set at like 70 Fahrenheit, which that's pretty standard for us is indoor type, but this is leaving water temperature. And the question is under different applications, particularly drop-in applications that have higher temperature water, what are those different leaving water temperatures that we might want to create multiple tables for? So this would be for these different scenarios. 110 leaving temperature, it's going to obviously look different for 140, 160. So trying to land on some agreement around that this kind of performance information so that we can really create those performance maps is another area, likely very important, probably of the highest value as part of the spec and the product list. I think is probably this kind of extended data. Next slide. So this is, I think we're weeks away from posting a request for comment, kind of walking through our thinking and seeking input from stakeholders, whoever they are. And I'll definitely make sure, John, you get it so you can share with this group if I don't really have, if folks in this network aren't really part of our network. So stay tuned. Hopefully it's very sooner than later we get this out.
Thanks, Dave. I think we can, any questions for Dave? At this point, we can pause and questions for Dave or any other presenters. I had a question procedurally. Typically, does NEEP get ahead of, and NEEP and CEE, do you get ahead of Energy Star specs, or are you typically waiting until the Energy Star spec comes out? And what is the thinking on, the possible current status of Energy Star?
Sort of two questions there a little bit. I mean, I do not know the latest and great. My assumption around Energy Star is that their that boiler spec process that they were starting a year and a half ago now, or even I don't know exactly. I can't imagine that's going to be moving forward quickly, but I might be totally wrong. They might be accelerating and trying to get that done. I don't have an update on sort of where Energy Star is. So I'd say between the specs, the performance side and the extended data side, I think on the performance side, we'd likely align with where an Energy Star, if they were to come to market quickly with a seasonal metric or some series of performance metrics, we would probably we'd likely align with that. I think what the role of the NEEP spec in that case would really be that we're that repository for the extended data and making that data available to the market. So hopefully that, I think sort of generally that's how it works. Our current air source heat pump spec is lower than where CE and Energy Star have. They've risen the bar beyond where Energy Star beyond where NEEP is. So in that, I guess, example, we are the data is really the value the high value piece of the NEEP product list, because we're not really driving the market towards the very highest performing systems.
Great, thanks. Charlie.
Yeah, I was kind of surprised that there wasn't more emphasis on hydro air installations, because when people buy a heat pump, they want cooling as well as heating. I mean, I know the utilities and the one I work for want people to heat, with electricity, but the customers want to be comfortable. And if you're putting in a heat pump, so that just begs the question: what kind of indoor fan coils? You got to have something with condensate drains to cool. And I'm surprised there hasn't been more discussion on getting both heating and cooling out of air to water systems, because you certainly can do it with the right indoor units.
I would just one quick follow-up, Charlie. We would definitely. I mean, my assumption is we would include the same kind of cooling performance reporting as heating. So that was one example. I gave the example of heating, but our current performance reporting requires cooling and heating data. So at least from the product list side, I mean, we might have that data, but then you'd have to, there'd have to be some kind of standard way of how manufacturers set up whatever their distribution mechanism is for cooling. Would have to be either at least just would have to be reported. I think actually 550H or 550 590 might be has more is a better model, I think, on for cooling metrics, and maybe.
Well, I wasn't talking about the metrics specifically.
Yeah,
I was talking specifically about installing products that do both heating and cooling. You're going to have to adapt from something besides radiant floors. You're going to be ice skating. You're going to have to have wall units or put in hydroware, or I was kind of expecting that there would be some focus on providing heating and cooling with an A2, because there's plenty of models out there that do show that.
I will say that based on the sites we've investigated, it's there is intent, but it's just additional money, unless if it's new construction, then you can reasonably say, okay, I can put some registers wherever I want. But in a retrofit scenario, especially in an older building where you might not have insulated pipe anywhere in the system, it might be going through walls. You'd have to run new pipe or rip out.
Yeah, I was a heating contractor for 8 years. I get it. I understand all of this. I sold more radiant tubing than anybody in Western Mass in 96 and 97, according to Stadler. I understand this business, but we're not in that business anymore. We're moving, in a different direction. It's not just heating. And I don't think people are gonna jump all over an expensive heating upgrade if they don't get cooling as well. That's all I meant.
I'm with you. That's been the challenge in New York, as I said in my presentation, right? Is that people are seeking cooling. When you don't get the cooling out of it, they're like, well, I'm going to go with these other products that are also electrically driven, efficient heat pump driven, but I get the cooling. The one thing I thought would be amazing was, especially with these houses that are radiant baseboard and they, the lower leave water temperature, if you couple that with a ductless hydronic fan coil in the same room, you get that a little bit of extra heating boost to supplement what you are losing out of. And then you also get the cooling. And when you're in a region that has like a 3-to-1 heating to cooling ratio, that's enough cooling, right? It covers your load or pretty darn close to it. The problem there, though, Charlie, is just like the actual app, putting it in, right? Running the pipes, getting them into a spot that works, getting the condensate out, the cost balloon way higher than what anyone wants to accept, and you just revert to the alternative technology options that are still heat pump.
Oh, cool. Yeah. Thanks.
Or Chuck in a window
let's
unit.
pass this to Hugh. Hugh, what's your question?
Yeah, I just wanted to point out, so there's a new standard being developed, 1700, and of course it's a weird world now. It used to involve EPA and DOE, but they've all backed out, so it's just the manufacturers now. And of course, that's taking the place of 550, 590, and I'm sort of casually involved or partially involved. So one thing they're talking about is going to a leaving water temperature of 135. And they're choosing that basically because most products can do that. And I guess, and of course, the EPA point and the Vermont point has always been a cold outdoor air temperature and a very optimistic leaving water temperature of 110. And I guess my question, so Scott had posted the EPA test standard from the first of the year. I had never seen that. What are the test points in that, Scott Spielman? Have you looked at that?
Oh yeah, just to clarify, that is for commercial heat pump water heating systems. So it's for air to water heat pumps for potable water.
Oh,
but
okay.
I just thought it could be a decent kind of framework to use, so that the test points are different than what you'd need for hydronic.
Got it. Okay, that's why I was confused, because I didn't know that happened. And I know the EPA had talked about doing something, but I assume it's mostly kaput now. But I guess my question for the group, or my warning for the group, is, there might be different rating points coming. And so, and like I said, I'm casually involved in 1700, and they do talk about keeping the legacy point of A5W110. But what happens if we don't keep that rating point is my question to the group.
$135 seems high to me for a good install, but
well, and so one thing I'll note from the test is that you often, there's kind of three temperatures, right? There's the temperature that you have in the distribution system. There's the temperature that the heat pump sees, coming out of the buffer, come out of the buffer tank and back into it. By the time, I've never seen a practical system where it's a whole lot lower than 135, to be honest. I don't know. Do you have different experience, John?
I am going to pause on that so I can give the last minute pitches for this meeting, and folks can stay and discuss. I'm happy to stay on for a little bit longer, but I want to do the closing first, and then we can return to it. So AWHI is doing an air to water heat pump manufacturer roundtable on June 25th. Look out for communications on that. We're going to be talking to LG, Siebel Eltron, Enertech, and Chiltrix. So, I will send out more communications as we get closer to that, but it should be interesting. Folks touched on this. We are interested in anyone who can present on multifamily applications, new studies, and really diving into cooling and distribution. All of those would be interesting topics. So if you feel that you can, or somebody that you want to volunteer to present, send me an email and CC them, and we'll get that conversation going. Our next meeting is on the 11th. All right, yes, folks who still have questions, who still want to talk, feel free to stick around. And Hugh, what was the last point you were making?
Yeah, my point is,
thank you, by the way, to our presenters. Sorry. Thank you, Phil. Thank you, Dave. Thank you, Matt. Great presentations. Really appreciate it. All right.
You're welcome. Thanks, everybody. Thanks, John.
Thank you, guys.
Yeah, it's great. So yeah, my question was, do you really think 135 is so high, or so are you seeing systems where the average temperature into the heat pump is lower than 135?
Into the heat pump? You're saying incoming water temperature?
No, I'm sorry. So leaving the heat pump, right? So So I'm kind of saying to get 120 in the baseboard or the floor, you usually need 5 or 10 degrees warmer when you consider the buffer tank. So I guess what are you practically seeing leaving the heat pump typically?
Yeah, I guess we could look at our 5 degree. We have actually decent 5 degree data at a few sites, but I feel like it's switching between space heating and domestic hot water. For space heating, I would guess at 110, maybe even lower, for our one site. And then domestic hot water, it's higher. It's at like 130 or, above.
That 110 is precipitated because they have radiant floor, I assume. So they don't want
Right.
130-degree water. There's a control telling it to do that.
Right. It is kind of an awkward thing where like the current paradigm cannot service radiators, but radiant inflow is like also a different weird. So like 135 is a compromise that is not a good compromise in either case. Like it won't work for radiators, but it's also too high for a good install on a radiant inflow.
Yeah, that might be true. It's it's stuck in the middle. Yeah, that might be true.
Which might be fine for a COP measurement, but I also, from the systems I was looking at, their COPs are really, really bad in that range.
Yeah, the one they're really good up to, and then they start to drop off as you get hotter leave water pretty quickly. And some are doing better than others. And that's what it's a 5-point variable problem now, right? You got outdoor air and the leave water and the distribution type all coming together to be a actual like home COP, and just good luck. Right? Good luck coming up with one metric that makes sense for those use cases.
Yeah.
I don't think 135 makes a lot of sense to be like a center point for a seasonal COP though.
Yeah, I kind of agree too. So yeah, so I'll keep you posted. And so I'll communicate that back to 1700. They don't always listen to me, but I'll.
Everyone listens to you, Hugh.
Yeah, not manufacturers. They don't listen to anyone. Yeah.
Anybody have any other post-meeting things they wanted to chat about, or are we ready to close? All right, great. Well, I appreciate it. Thank you, everyone, for hopping on. Great discussion. And I'll see you in 7 or 8 weeks.